This is projects, the package delivery system. We have 7 files here. Config.json is where all our settings are. Things like the number of the trucks, the truck capacity, how many generations to run. You can change any of that without touching any code. Then we have generator.py. In generator.py is what creates the random variable map. Then also we have uh, problem.py. Problem.py is the main one. It handles all the distance calculation and turns each solution into real truck routes. Then we also have NSGA-II.py. In NSGA-II.py is where the NSGA-II algorithm runs, and we use the deep library for that. Then we also have solver.py. In solver.py, solver runs everything together and save the results. You can also see we have a visual.py, visualizer.py. Visualizer.py is the draws the all the graphs and also we have a the main.py. The main.py is the just one file we run to start the whole things. Then okay, um, I can now run a code, but see how it works. I will type the command, which is Python main.py. Let's see what's going to happen. It's loading. Wait for the test to print. Okay, we we just run the code already now. So we just run one command and it handles everything. Then you can see uh, okay, from the header it prints. Then you can it shows from the header it prints. It shows uh, okay. You can see um, for the test, first it generates two test case here. It generates two test case here. Then deports 30. Um, deports is so we have two deports here. Then 30 recipients. Total demand of 536 units. Then also um, the this problem section to print. The problem section to print. We have 8 trucks here available. We have 8 trucks available. Then each one can carry up to 100 units. The population size of 100 also running for 200 generations. Then wait for let's see what the generations will print. With generation 1 to print. Okay, you see the 200 generation. Let's see what it prints. Then in generation 1, uh, the best distance is 1,446, and the cost is 3,115. These are just random solutions at the points, so they are quite bad, you know. Let's see what 50 um, generation print. In 50 generation print, uh, by generation 50, the distance is already down to 1042. Then um, 1042, well, is a big improvement. The algorithm is finding better routes by combining and mutating the good solution. And from 100 to 150, generation 100 down to 1013, um, generation 150 to 952. You can see, then it's still getting better, but more slower now because it is getting close to the best solution it can find. Then, and by 200, um, then and by generation 200, the best distance is 952, 952, and the cost is 2,381. The whole thing finish in about the whole thing finish in about 5 seconds. I think yeah, the whole thing finish about 5 seconds from the 5 seconds. We found 6 unique Pareto solutions. Look, look at the solution. Look at the solution one. Shortest distance is 952. Shortest distance is 952 and 52. Shortest distance of 952 uses this truck, maximum of 6 trucks, maximum of 195, and the cost is 2,381. Now look at the solution 2. It uses 7 trucks, so the maximum drop to 194, but the distance drop to um to 1,060, then and 1,060, and cost goes up to 2,050. None of them is the best at the everything. Each one is different trade-off. That is exactly what a Pareto font is supposed to show. And here are the actual delivery routes. For the best distance solution, truck, best distance solution, truck, truck 6 went out. Truck 0, 0, truck 0, truck 0 left from depot 0. Then truck 1, depot 0. Then truck 2 left from depot 0. Truck 3 left from depot 1. Truck 4 left from depot 1. Truck 5 left from depot 1. So 3 truck 3, truck 4, truck 5 left depot 1. Then truck 0, 1 left depot 0. So the numbers in the brackets are ID. The numbers in the bracket, which is you see here, is the customer's ID. Um, 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 each truck visits, each truck visit in order. So the truck 0 left depot 0 and visited customers 29, 15, 24, 10. Then and in that order, carrying 79 roads units and drove a distance of 195 units, all 30 customers, and no one went over the 100 unit capacities. You can see no one is above 100 capacities. Then we can now see from the map. So this is first graph, shows three routes side by side. The stars are two depots, D0, D1. The numbered dots are the 30 customers. Each colored line is a different truck's full journey. It starts at the depot, visits its customers in order, and comes back to the same depot at the end. The rest map is the solution with the shortest total distance. The middle one has the shortest make span, meaning all the deliveries finish the fastest, and the right one uses the fewest trucks. You can see they all look different, even though they are delivering to the same 30 customers, because each one is optimizing for something different. This is the main analysis graph. At the top, we have 6 scattered plots. 1, 2, 3, 4, 5, 6. One for every pair of 4 objectives. Distance versus marksman. Distance versus truck use. Distance versus cost. Then and so on. Each blue dot is one of our 5 Pareto solution. The red line connects them to show the trade-off as distance goes down, makes man trying to go. You cannot have the best of everything at the same time. The graph at the bottom at bottom left shows how the algorithm improved over 200 generations. You can see the distance and cost both dropping. Most of the improvements happened in the first 100 generations. Then it slowed down, and the giant chart on the bottom right shows each truck as a colored horizontal bar. The bar starts at the 0. Then truck reached ends when it goes back. The red dotted line is the maximum span. The moment when the last truck finishes, any truck whose bar ends before that line was already back at the depot waiting. So that is our project. Um, one command does everything. It generates the map, runs NSGA-II for 2000 generation, and shows all the results. We got 5 different solutions, and you can pick whichever one suits what you need most. If you care, if you are more about saving money, if you care more about saving money, you pick solution 1. If you want the faster delivery, you pick solution 2 or 3. That is the whole idea behind multi-objective optimization. Thank you.